So the last section in our first unit that we're going to take a look at actually isn't in chapter 1 in the book, but to me it makes sense to talk about now. This is section 3.5 in your textbook, and we're going to talk about limits at infinity. Not infinite limits, where we got infinity and negative infinity as our answers, but rather what happens as x approaches infinity and as x approaches negative infinity. I'm going to call this thing f of x, and I want to find the limit as x approaches infinity of f of x, and I want to find the limit as x approaches negative infinity of f of x. That first question is asking, as x gets close to infinity, as x gets really, 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 really big, like over here but further and all the way over there, what's happening to my y values? This one over here is asking what happens as x gets close to negative infinity, as x gets very, 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 very negative. What happens far in this direction? This whole section is about trying to figure out what happens on our graphs far to the left and to the right. What happens on our graph far right or far to the left. So this first one, as x approaches infinity, as my x's get really, really, really big, my y's, they're leveling out. They're approaching a y value of 2. And I'm going to say that the limit as x approaches infinity of f of x equals 2. Similarly, as x approaches negative infinity of f of x, as my x's get very, very negative, my y's are getting really, really, really close to negative 3. I don't care at all about what's going on in the middle. This question is asking what's happening far to the right on the graph. This question is asking what's happening far to the left on the graph. I'm using infinities like in the last section, but in a very different way, and this really has nothing to do with the vertical asymptotes we talked about last time. Actually, this is talking about horizontal asymptotes. What I'd like you to do is I'd like you to take a look at that section 3.5 worksheet, Graphical and Numerical Limits at Infinity, and see what you can do with this entire sheet. Pause if you're on YouTube. Otherwise, Edpuzzle will just stop, and you'll submit some answers. See what you can do. Okay, well, as x approaches infinity, that means when I'm going far to the right, my y values are approaching 1. I don't care about any of this fancy stuff over here. None of that matters. As x approaches negative infinity, that means as I'm going far to the left, my y values are approaching 2. That's it. Nothing else on the graph matters as far as these are concerned. Now, I guess if I gave you something like asking you what the limit as x approaches 2 of the function is, and the limit as x approaches negative 1 of that function, as my x's get close to 2, my y's are going way up. In this case, this answer is going to be infinity. As I approach negative 1, well, my y's are going way up, but also way down. That one does not exist. What I need you to realize is these and these are totally different questions, which we look at in a very different way. Far right, far left, what's happening right? What's happening as x gets close to 2? What's happening as x gets close to negative 1? And these are in the middle of our graph. In number 2, as x approaches infinity, well, as I go far to the right, my y's are getting close to a y value of 2. And over here, as x approaches negative infinity, my y's are getting close to a y value of negative 2, so I'm going to say that. Number 3, according to the table, well, as x approaches infinity, that means as my x values get really, really, really big, 1, 10, 100, 1,000, 10,000, yeah, my x's are getting really big, but my y's, they're leveling out. And looks like they're leveling out at 2. As x approaches negative infinity, as my x's get very, very negative, -1, -10, -100, 1,000, and so on, my y's are leveling out and getting really close to a y value of -2.